Hello, today we're looking at the y-intercept and how it is related to the equation of the straight line y equals mx plus c. Now last week we looked at y equals mx plus c and we found how to find m, the multiplier, when you're working out the gradient of x. Today we're going to be concentrating on the c, the gradient. Now we use this by finding the y-intercept. Now here I've got some graphs drawn on a traditional Cartesian grid. Let's have a look at graph A first of all. Now, straight line graph, it means that we can use the change in y divided by the change in x to find the gradient of this graph. Now, let's have a look. I'm going to choose this part here because it comes through nice and easily. We're going change in y is 2, change in x is 4, so it means to find the m, we've got 2 over 4, which gives us a gradient of a half when simplified. Lovely, nice and easy. Now, when we're looking at this, we need to find out how far up or down this graph has moved. And in fact, A goes through the origin, it goes through 0. So from the original y equals half x, it isn't moving. So say for example, if we take 4, let's write this down actually so you can see, y equals half x, where m, the multiplier, is a half because we've calculated the gradient. So x is 4, half of x is 2, so y is 2. X is negative 6, half of negative 6 is negative 3, y is negative 3. So that, because it goes through the origin, through 0, 0, that is the equation of the graph there. Let's have a look at B. Now, because all the lines are parallel, and again last week you looked at the fact that when you have parallel straight lines, the gradient is the same. So you can see by this diagram, follow it up, and you can see that these lines are parallel. But actually, what have I done to this graph? How have I moved it? Okay, let's line that up again. What I've done is I've taken the line y equals half x and I've moved it up. It's gone up. How far has it gone up? Well, how far it goes up we describe by where it crosses through the y-axis. And where it crosses the y-axis, this is what is called the y-intercept. I'll jot this down in a minute for you. Now you can clearly see the gradient is the same. So the gradient is half of x, okay? And it goes through on the y-axis, the point 6. So therefore we can describe this graph as y equals half x plus 6. I'll go through that again. And again, the reason there, that's where the plus 6 comes from. Okay, so the gradient, same as you were calculating last week, change in y divided by change in x. Okay. Oops, throwing the pen around. This is the original. This is the one that we know we can calculate easily. We can also calculate the gradient of this, but because this graph B is up 6 places, up 6 positions, we call it y equals half x plus 6. So the gradient is a half and we're adding 6. Counter to that, if we look at graph C, I've drawn down here. Pull it down. How far down have I gone? Well, I've gone down 5 places. Although I haven't got the number on the graph, we can use our knowledge of how graphs work. We know that point there is where they cross. Let's move the plastic out of the way. It's there. And that point there is -5. So obviously if you printed out your graphs, you can jot them down. If you're drawing them by hand, that's fine as well. So this equation here is still your y equals half x, your gradient, -5, because it's going through the y-intercept of -5. Okay, so just to recap, that C is the y-intercept. It's the point where the graph crosses through the y-axis. As normal, pause the graph, and I want you pause the video even. Look at these 3 graphs, and I want you to find the y-intercept where these 3 graphs cross the y-axis, and then check back in to see what your answers are. Okay, so let's have a look and see what you've got. Here, the graph goes through 6. So for this graph here, for D, the y-intercept is +6. And remember, it must always have some sort of positive or negative, or maybe even neutral, obviously, if it goes through 0. E here is -5. And here, right down here, is -13. So it goes through 6, goes through E, goes through -5, and F goes through -13. Now, to find the equation of the line, you are combining the two. So read the question carefully. Sometimes they just want the y-intercept, sometimes they want the full equation. So we can see clearly these 3 lines are parallel, so we can find the multiplier easily because they are parallel. I'm going to take, let's have a look for a nice clear chunk. I'm going to take this chunk here. And we're looking for your change in y compared to the change, divided by the change in x. We're going up 4 here, we're going 2 here. So when we're calculating this, our multiplier, mx plus c, is your change in y divided by your change in x, gives us just 2. So we can combine this information here to find the equation of each of the lines. Y equals 2x plus 6, y equals 2x minus 5, and y equals 2x minus 13. Oops, that doesn't look like minus 13, that's better. So you are combining the 2 pieces of information, the change in y over the change in x, and today we're looking at C, the y-intercept, and how you combine the 2 to find the equation of the graph.